Next, we look at shuffle 43, bottom row on the left. It begins the same as all of the shuffles in our document on the left. The only difference will be the stacking. But of course, the stacking order significantly affects the ending order of the packet. Okay, so let's go ahead and demonstrate shuffle 43 by using our ordered packet 1 through 8. Okay, so what is an R, LR with this stacking? Well, we just begin with an ordinary LR shuffle, just left, right. And then for each half, you perform the LR shuffle again. Okay, left, right. Now the stacking here is this leapfrog stacking. So remember, this is pile 1, 2, 3, 4. So pile 1 will go on top of pile 3. Pile 2 will go on top of pile 4, and then we'll stack left on right. So 1 goes on 3, so it's like it's leaping over its neighbor. 2 gets stacked on top of 4, it leaps over its neighbor. And now we stack the left pile on top of the right. So what is the new ordering of the cards? And what will the permutation notation be for this reordering? So the new order is 3, 7, 4, 8, 1, 5, 2, 6. Expressing this in Cauchy's two-line notation, we obtain the following. Of course, the top row is always 1 through 8. So we get 3, 7, 4, 8, 1, 5, 2, 6. Converting this to cycle notation, we obtain the following. 1 goes to 3, so there's an arrow from 1 to 3. 3 goes to 4, so we have an arrow from 3 to 4. 4 goes to 8, so we have an arrow from 4 to 8. 8 goes to 6, an arrow from 8 to 6. And 6 goes to 5, so an arrow from 6 to 5. And finally 5 returns back to 1, so it cycles around, completing a 6 cycle. So what happens with the remaining values 2 and 7? Well, 2 goes to 7, so we have an arrow from 2 to 7. And then 7 returns back to 2, which cycles around, giving us a 2 cycle, also called a transposition. Color coding the digits, we obtain the following. And as a reminder, the position values 1, 4, 6, 7 are color-coded black. The position values 2, 3, 5, 8 are color-coded red. This will help us keep track of what happens to the Bessey sequence structure of our packet after the shuffle is performed. And also recall, if the sequence structure is preserved, then we express it in this way. And what that would mean then is the cards that originally began in positions 1, 4, 6, 7 after the shuffle are somewhere in those same positions, maybe moved around. And the cards originally in positions 2, 3, 5, 8 also stay within that set of position values once the shuffle is completed. Now that's in contrast to the inversion. An inversion occurs if the cards originally in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8 and vice versa. So there's like a wholesale exchange of where the cards are located relative to our color coding system. So in particular, we can see that black 1 goes to red 3, which goes to black 4, which goes to red 8, which goes to black 6, which goes to red 5, which wraps around and goes to black 1. Red 2 goes to black 7, which wraps around to red 2. So we see here that each value gets sent to a value of the opposite color. And when that happens, we say that inversion has occurred. So here we have the Bessey sequence 1001, 0110. So let's go ahead and perform this shuffle. And the claim is we should get an inversion of that sequence. Okay, so it's left, right, left, right. Same thing for the two halves. Left, right, left, right. The stacking is this leapfrog stacking. So 1 gets stacked on top of 3, 2 gets stacked on top of 4, and then we're stacking the left pile on top of the right. So what we should get now is the sequence 0, 1, 1, 0, 1, 0, 0, 1, which we do. So this simply shows that all of the cards have been moved to different locations, and in particular, the cards that originally began in positions 1, 4, 6, 7 are now located somewhere in positions 2, 3, 5, 8, and vice versa. And taking a look at the shuffle diagram for shuffle 43, we find the following. Of course, we have our 6th cycle, 1, 3, 4, 8, 6, 5. So what that means then is if we begin at 1, there should be an arrow from 1 to 3, which there is, an arrow from 3 to 4, which there is, and an arrow from 4 to 8, and then an arrow from 8 to 6, and then an arrow from 6 to 5, and finally an arrow from 5 returning back to 1, completing a 6th cycle. We also say that these 6 values constitute an orbit, and that simply means that these values move around among themselves each time this shuffle is performed. And finally, we see that we have a transposition. So we see we have a double arrow between 2 and 7. And so that completes our shuffle diagram for shuffle 43.